binary, and we're going to work on being able to do two things. First, convert from base 10 to binary, or what we call base 2, and then to go the other way to convert from binary back to base 10. Now, base 10, if you don't know, that's what we use every day. Okay, that's our normal numbering system. All right. So you can kind of think about it. Why do you think we developed a base 10 system? Does anybody have any ideas? Probably, right? Probably because we have 10 fingers. And that's one theory. Okay. What was your thought? More accurate. Okay. How do you think? I want you to think about this. And how is it more accurate to count in base 10 than say base 6? Okay, look, I want you to think about that, and if you can come up with an answer, I'm really curious about that.
You could just say my answer's wrong.
No, I'm not saying that. Okay, I'm not saying that it's wrong. It's curious.
I feel like it's easier to represent values with a base 10.
Well, that's what we're used to, so it's much easier. Don't get base 10 confused with like how in the metric system, everything's divisible by 10, and in feet and inches, you have 12 inches. So that's not what I'm talking about. Okay. So that's that's what you were talking. Yeah, that makes sense. So yeah, and if you're talking about like measuring, and that, it makes it a little easier to do the math, right, than dealing with all the fractions. All right. So what you have is a set of coins, okay, and a little table, and when we go through these little tables and I just keep one of these in my notebook, and I'll draw it over and over again because it really helps me, just like the one I've got on the board. And so I've got each one of those things represented to their power. And if you don't know, any number to the 0th is 1. Okay? If you didn't know that already, because that's a little confusing to some people. So we start there, and the coins that you have are going to be the same values that represent here. Okay. Now, I used to watch this TV show called Numbers, and you guys probably may or not have seen that. It was an FBI agent, and his brother was like a really smart mathematician, and so he'd always end up having to bring his brother in to help him do some math to solve a crime or something, and then they'd catch the bad guy, and it was a lot of fun. I liked the show. But one of the things he said in there that was kind of interesting to me, and there's a law, and I don't remember what it's called, but it's about giving change back, okay? That if you have a full, like in a change drawer, if you have a full drawer full of change, and I'm going to give 55 cents back, I'm not going to give you 5 dimes and 5 pennies, right? I'm going to give you 2 quarters and a nickel. I'm going to give you whatever's the most efficient. And so we can kind of think about that when we're doing this, when we do this conversion that we're about to do. So I want you to think about it. You're going to use the biggest value that you can. Okay? Does that make sense? All right, so if I just real quickly, if I said I want to do a number, say, let's say 5 in binary, okay? And each one of your coins is worth that much, okay? So I would take my coin, and I would say, well, what out of that's the biggest? I don't have a 5, so I've got to go down here. So I would place my 4 coin, right? I would place it there, and then I would place my 1 coin there. And I know that those two things together equal 5. You with me on that? Because I have 1 coin worth 4 and 1 coin worth 5. Now underneath that, if I just, every place that I put a coin, I put a 1. There's no coin, it's a 0. And that is 5 in binary. Okay. Each place, just like in the tens, if you think about, if we have that same thing in the tens in our place values, we're used to that, but it's always a multiple, this is our ones, this is our tens, this is our hundreds. So if I wrote 101 in base 10, you would know that this value is worth 100. This is a 0, so it's nothing, and this one's worth 1. So when you added those together, you would get 101. those, we don't think about it like that because we're so ingrained, but each of those place values has a worth. It's worth something, right? And the same thing goes in binary, that each one of those place values is worth something. So each one of those ones represents something. It represents one of these powers of 2, okay? So on your sheet right now, I want you to do, let's go 9. I want you to put out your coins, and then you can and add up to 9. Whoop, I'm gonna go back to that one. Where is that? So get your coins out, put them on your sheet, and then write your binary below it. I'll come around and check, see how you did. You can write your numbers below that. Good. Perfect. Everybody's perfect there. Good. All right. So let's do another one for practice. Let's do 13. Let's do 13. Good. Yes, on that one, we would come and I can't go 16, that's too big, right? So I have to go a coin of 8, coin of 4, nothing there, and then I need a 1. It equals 13, so in binary, looks like that. Not too bad, right? Not too bad. Okay? So let's try a bigger number now. Let's try, let's go 22. I'll just write it up there so we know. Let's try 22. Good. So we came and we said we need one that's a value of 16, and then 16 plus, we can't go 8, that's 24. Hope I don't mean to write there. It's writing a 0. So they're gonna have this guy, that gets me to 20, and that gets me to 22. So here I'm gonna go 1, 0, 1, 1, 0. You guys got that? Okay. All right, let's go one more. Let's go 158. One, 5, 8. That's not right. Oh, no. This one's a 0 too, isn't it? There we go. That's it, isn't it? So you got something that looks like that, and everybody got that? That's pretty good. All right, so now we can also use this same chart to go the other way. And just so you know, we can also, anytime we're going from our base 10 to our base 2, we can also, and I'll show you how to do this too, a deal called binary or successive division. Most people that I have in class don't like the successive division method. I'll have a couple that'll be like, oh, I got that. They like long division, and so it's kind of like long division, and they like it. This is an easier way, I think, to do it for me, but we can also do this chart backwards, and it looks like, let's just take a number like, let's just start with, if I just put in 1, if I just go from binary, okay, let's just say that those are my 1s. Well, what do I do here is I just add up those values. So I could put my coins back on there if I wanted to, and I would say, and I'm just going to say 4 plus 2 plus 1, and that gives me 7, okay? So I can work this backwards as well, okay? So you can work it backwards. I can do another one. Let's do another practice one. Let's just say that I go, and I say, what is that number in base 10? What is that number in base 10? Well, I'm going to take 32 plus 8, and I'll just put my plus, and I'll go 1. If I add those things together, I've got 41. See how I'm doing that? Does that make sense to you, Carolina? Good with that? Okay. All right, I'm gonna give you one to practice with. Let's go. Let's do that one. Good. Everybody got that? Good. You got 26. All right, let's do another one.